require a data stage, or why do we require an ETL tool? What is the basic requirement of it? What do you think?
Yeah, according to me, this is a tool
Mm-hmm.
to load our MAR tables, and those MAR tables we use for reporting, for business
Okay.
perspective.
Okay. Now my question is, can't we load that with the help of query? Firing a query or a stored procedure, than having an so highly like expensive ETL tool, and then we require so much professional. Then why would a company go for ETL tool? Why can't they have just a query in Oracle or SQL Server or whichever database they are using, and they can load the data into data warehouse,
Okay. According to me,
right?
I think, yeah, according to me, I think that designing such a complex query, it will try to
Mm-hmm.
create big time tables in the time space of database, and that
Okay.
will slow down the performance.
But don't you think spending crores of rupee in an ETL tool, it's better if they can build query?
Sorry, come again.
Instead of having such an expensive ETL tool, they can have query, some experts writing query, maybe they can hire 3, 4 query. Here they need to have an extra tool and needs to have certain like experienced professionals. So it's a two-way like expense for a company. Still they prefer for ETL tool. Any other point you can think of
Mm,
apart from that? Any other point? I agree, one point is like it's very difficult to develop complex logic. Any other point?
and ETL tool is a very faster tool. We can process the data in parallel and partition the data.
No, currently I haven't come to data stage. I'm just saying about ETL.
ETL.
Like why do we need an ETL tool? Let's say it don't have, even parallelism is present in Oracle, right? We can process the data in parallel.
Do we have this feature to load this flat file into database in using SQL?
Right. Actually, this is the main reason why we need an ETL tool. It helps us to integrate the data from multiple sources into a common place. Okay. Multiple sources, let's say, if you are, as I said you previously, if you are having a data warehouse, if you are having an, as I said, we can fire a query, then we can fire only at one database. Okay.
Right.
But if I want to load in one job from sequential file, from SQL Server, from Oracle, from DB2, if I want to load data from multiple sources, this is the main reasons why we need an ETL tool, in order to integrate from multiple sources. Plus, it provides us the benefit of, as you said, the degree of parallelism, the processing speed is fast, since the tool is totally GUI, so it's easy to load or use the tool rather than building a query. Here we just need to drag and drop.
Yeah.
Okay. So this was basically that's why we need an ETL tool. Okay. Now here comes data stage. Now currently Datastage is one of the leader in the market, and it is going at a very fast pace. It is the product of IBM. Okay.
Okay.
Now why Datastage is having an edge over other, its similar ETL tool, let's say Informatica or Ab initio, is the degree of parallelism it uses. Okay. The other ETL tool does not use the parallelism that effectively, as effectively it was used by Datastage. Okay. So the processing speed of data is very fast as compared to other ETL tools. Because Ab initio has the parallel processing speed, the problem is that Ab initio is very costly. Okay. SSIS does not give the performance. Informatica does not implement the parallelism effectively. So that's the reason the Datastage is now growing at very fast pace in the market. Plus, it's a product of IBM. So IBM, since IBM is already a software leader in the market, so it tries to sell Datastage to its customer. Let's say it tries to sell complete suite with having database as DB2, ETL as Datastage, and reporting as Cognos. So it tries to tell like a complete suite. So that's the reason also Datastage is going popularity in market. Okay.
Yeah.
Datastage is basically a GUI based tool which is just you need to pick and drop from one point to another, and it's totally GUI. You hardly have to do any coding. Okay, you can easily handle all types of metadata in data stage. You will have aggregate data, and you can transform and load the data into data warehouse. Okay. Now, as I said you, the data stage is getting edge over the market because of parallelism. Okay. The parallelism comes from the number of hardware which are present in the data stage server. Okay. Number of hardware in the sense, number of CPUs, central processing units, or the processors which are present in the system. Let's say if your data stage server has 6 CPUs, then it can process data 6 times parallel.
Okay.
Okay. So you can't apply the parallelism by yourself. For that you need to have a supporting hardware at your data stage server. Okay. This hardware makes you like how many degree of parallelism you can use. Okay. Now there are 3 types of systems which are present. One is SMP, clustered, and MPP. Okay. SMP is symmetric. Yeah.
Yeah. Is there any way to find out how many processors are there in the database server?
You need to go hardware. From hardware you can find out. In control panel there is an hardware option. From there you can go and see the number of processors.
Okay, in server itself.
Right.
Okay.
And basically from development point of view, this is I am telling you just for your information, but from development point of view, you would never like allowed to access data stage server directly. Okay.
Yeah, right.
Every time you will be present, go to the client and you can work on the client. But I will install during this training, I will install data stage in your machine. Okay. The server would be present in your machine. At that time, you can easily check the server. Like whatever query you are having, I'll show you that.
Okay, sure.
Okay.
Yeah.
So as I said you, there are 2 types of system. One is SMP and another is MPP. SMP is the kind of system which is mostly used in server jobs in which everything is shared. Okay. The hard drive is shared, the disk IO is shared, everything is shared. By MPP is the system where everything is dedicated. The hard disk is dedicated to a particular CPU, the IO is dedicated, everything is dedicated. Okay. So in a nutshell, you can say that when the hardware is shared among various CPUs, then it is called SMP. But when it is separate for all the CPUs, then it is called MPP. Okay. In parallel job, we mostly prefer MPP system. Okay. Now, why the requirement of parallelism comes into picture. Okay. Why do we need parallelism? There is 2 types of parallelism which is followed in data stage, which is partitioning, pipelining, parallelism. Okay. Now why we require, first we understand that, then I will tell you why we require partitioning and pipelining. As you see in this job, when there was no partitioning, pipelining, parallelism was present, at that time, during traditional batch processing, every time we process the data, we need to store the data in a disk. Okay? In a landing disk, let's say if we extract the data from a flat file, then we store in a disk, then we fetch from a disk and load it to transform, then we store in a disk, then we clean and load it to a disk. Okay. So if you have 10 GB of data, it requires in current scenario 70 GB of processing resources. Okay. So here when we were using very large batch, the traditional processing, in that case, it was very difficult to hold or to process the data, or the hardware required was very large. Okay. So Datastage comes up with an option of pipelining multiple processing. Okay. In pipelining multiple processing, data is not stored in a disk. Okay. Data keeps on moving within the job simultaneously. Let's say if you are having 1000 rows in your source and 10 rows got processed, then it will move those 10 rows for cleansing. It does not wait for all the rows to complete, then it will process the next job. Okay. While here it was processing all the rows, storing, then loading all the rows. So the storage area is increased. Okay. Here it is simultaneously processing the rows as it is transformed.
Which there is no temporary disk to store the data in the
right. Here we didn't require the temporary storage. It will directly keeps on processing.
Okay.
Move from one stage to another stage. Okay. It's same as like conveyor belt which is used. Data keeps on moving. It doesn't wait for all the packets to arrive, then it will send to next stage. 10 packets, then 10 packets to send to next stage, then next 10 packet will process and it will be sent. Okay?
Okay.
Is it clear? Pipelining multiple processing?
Yeah.
Then the next is partitioning parallelism. Okay? Now partitioning is suppose your source is coming, okay, source is having a data, then you will partition the data into multiple nodes. Okay. Partition the data in multiple nodes in the sense, suppose you are having 4 degrees of parallelism, you are having 4 CPU, 4 nodes. Then in that case, here you will send half of the data in one node, half of the data in another node, and rest of the data in third node. So in that way, your processing or the job is same, but the speed has become 4 times. Okay. So this is called partitioning parallelism. Okay. And data stage uses both pipelining and partitioning parallelism. So it is a combination of both the systems where source data is partitioned as well as pipelined simultaneously from source to target in a single job. Okay. Now there is a time arrive when we need to repartition our data. Okay. When the data is already partitioned. Suppose you have partition like, let's say, based on a employee ID in the stage first, and in second stage you want to partition based on name. Okay. So in that case we can use this repartition the data also between different stages. Okay. Now this is the physical job and virtually this is the job. Okay. Physical job looks like this, but inside Datastage environment it's like 4 jobs of same kind which are processing simultaneously. Okay. Now the same way we do a partition, at the target we do a collection. Okay. In partition we are partitioning from sequential data to parallel. In parallel and in collector we are moving parallel data to sequential. Okay. This is basically the character method where data from different partitions are stored in a common sequential. Okay. Okay. There are methods for these and we are going to discuss them in details in next upcoming slides. Okay. For these partitions and collections. Here, even from looking at job, you can say that whether the data is partitioned or not. Here you see this shows you that the data is partitioned, and this shows you that the data is collected. Okay, this symbol. So while looking at job also, you can say that whether my data is partitioned or it's collected.
Okay.
Now we are going to discuss about the partition method of data state. Okay, there are about 9 methods of partition used in data state, which is used to partition the data based on your requirement. Okay, first start with round robin partition. In round robin partition, if you are having 2 degree of parallelism and you are having 10 records, then first record will go to first node, second record will go to second node, then again third record will go to first node. Okay, so first to first, then second to second, then third to third, a third again to first. Okay, so in that case the partitions are of equisized. Okay, is it clear or not to you?
Yeah, definitely.
Okay. Now the second is random partitioning. In random, you doesn't know how the data is distributed, but data stage will randomly distribute the data among different partitions, and it will rebalance again so that almost equisized data will have in the all partitions.
Okay.
Okay, but in this method there will be a cycle. Yeah.
Yeah, is there any scenario that we can prefer the random partitioning over the random round robin partitioning technique?
Actually, once I explain you all this partitioning, then I will cover some scenario also that will help you to explain like where we need random or where we need this round robin or where we use same or entire. Okay. So in random we will use like extra overhead to have an equisized partition. Okay. So you can say this partition is also equisized, but it has some overhead to calculate the random extra processing. Okay. The third is same partition. This is the partition which requires the lowest like efforts for data state, and it is high performance partitioning. In this partitioning, it partitions the data exactly, keeps the data exactly as the previous partition. Okay. If previously the partition is random, then it will have the same partition and move the data to next stage.
Okay.
Okay. It won't change the partition. So this type of partition is called same partition. Now entire partition. Entire partition tells that data from input, all the data from input goes to all the partition. Okay. All the partitions in the sense, if you are having 10 records, then all the 10 records will go to partition A and all the 10 records will go to partition B2. If you are having these 10 records, then all these 10 records will go to this partition and all these 10 records will go to this partition.
Okay.
Okay. This is known as entire partition.
Okay.
Okay. So don't you think why we need this kind of partition? Where there is no meaning of partitioning, either it is deduplicacy, don't you think so?
Yeah, I think that when we are doing some lookup or join, so while doing lookup, means every all records should be placed in every partition. Then lookup can be successful.
Why, if I don't take every record, then what would be a problem? If I don't use entire partitioning, then what would happen?
Yeah.
No, will it give correct answer or not when you use entire partition?
I think it should give correct answer.
But if you are not using entire partition, then also it will give correct answer.
Suppose when I am doing lookup and it is using, it is trying to find out the matching record from one partition. So there is a possibility that for some record it cannot find the matching record from the source. So for some record there is a chance that it will not be able to find out the matching record.
Right, right, you are correct. So actually that is the case we require, but that is only in lookup, not in join. In join we basically prefers hash partition.
Okay.
Okay. In lookup only, since we need to, okay, this entire partitioning is in reference or in source?
This entire partition will be in source.
Sure?
Yeah. I think
No.
no. Okay.
This entire partitioning will be a reference. The source would be any partitioning, let's say hash or round robin or whichever.
Okay, means in the right part.
Right, right. At the top, the reference should have the entire partition.
Okay, okay.
Okay? Because you want to compare reference data, right, with all the input data. So reference data should be reference to all the nodes.
Okay.
Okay.
So this is just lookup stage, we use this entire partition.
Right. It's only in lookup stage we use entire partition.
Okay.
Okay. So if I don't use lookup stage and I use any other, like apart from entire partitioning, if I use hash partitioning, will my job abort?
I think it won't abort, but it will not find the matching record for some of the record.
Right. It may or may not be possible.
Yeah.
Right. You are correct. Exactly. Now the next is hash partitioning. Okay. In hash partitioning, it is basically a key-based partitioning in which the data is partitioned based on a hashing algorithm. Okay. Here we need to define a key, any key based on which the processing takes place. The main benefit of this hash partitioning is all the key having similar value goes to a single partition. Let's say if we are comparing two data sets having a key value as 1, so hash algorithm gives us a conformity that all the 1 value will go into a single partition, okay, whether it's from a source or it's from a reference.
Okay.
Okay. So whenever we are comparing two data sets or two files, then when we want to have data in only one partition for comparison, then we use hash algorithm.
Okay.
Okay. Hash algorithm partition. Now, okay, let me ask you this question, whether the data will be equisized in this partition or not.
I think it won't be the equisized partition.
Right. The data won't be equisized. Now the next is modulus partitioning. In modulus partitioning, it's a key-based partitioning, numerical key-based partitioning, in which the data is partitioned based on the key. Okay, key in the sense it will be a numerical key divided by the number of partitions, and whatever the remainder data goes to that partition. Okay.
Okay. Can you come again?
Let me give you an example. Let's say it's a, yeah. I'll explain you this with an example. Let's say you are having a key with employee ID 1, 2, 3, 4, 5, and you have two partitions. Okay. So in modulus partitioning, what it will do, it will divide the key by number of partitions. Let's say your input record is 1, which is divided by number of partition 2. So the remainder is 1.
Okay.
So in that case, the data goes to first. And when the record 3 comes, it is again divided by the number of partitions 2. Again the data goes to first partition. When 4th comes, then it is divided by number of partitions. The remainder is 2. Then it goes to second.
Okay.
Okay. In this partition, the data or the partitions are not equisized.
Okay.
Okay. Now the next is range partitioning. In range partitioning, basically we divide the data based on a particular range. Okay. Let's say if you want A to D in one partition, D to L in second, and L to K in third. So you can do that with the help of range partitioning. But before that, you need to create a range map by using range map state. Okay, for implementing the range partition. Now the next is DB2 partitioning. In DB2 partitioning, it is used when you are using DB2 stage. Okay. Now you may have a question, there no other database partitioning. Because Datastage is a product of IBM, so that's why they have included DB2. If it is not used any other partitioning, only DB2. Okay. And the most important partitioning is auto partitioning. Okay. In this partitioning, you need not have to do anything. You just select auto partitioning, and it will automatically partition the data based on your requirement. Okay. It divides the best partitioning method depending on the stage, and it will partition the data. So while during a job, you need not to worry whether I should use round robin, random, entire, hash. It will automatically partition the data based on your requirement, and it will load it.
Okay, means here automatically means it will choose any of the partition method, that is round robin or hash. Okay.
Right. You need not to worry. Datastage has that much intelligence, so it will. Now you might have a question that how Datastage is choosing what partition to use.
Yeah, right.
Right. So for this, I am having an answer like it depends on the stage. If you are using lookup, then Datastage will use entire. If you are using join or merge, then Datastage will use hash. If it's any copy, then it may use random.
Okay.
Random or let's say round robin.
Okay.
Okay. So it depends like the stage which we need to partition the data.
Okay.
Okay.
So these are the means for which stage it is using which partition.
Pardon?
So this is like predefined things in data stage, means for which stage it is using which partition method.
No, it is not defined exactly, and you can't even see Datastage is using which type of partitioning. Okay. But like few stages which are explicitly mentioned, like the entire partitioning is for lookup or hash partitioning is for join. Okay.
Yeah.
Apart from that, like it may use any partitioning depending on the requirement.
Okay.
Okay. But whenever we are using any processing stage, it mostly prefers to use hash partition.
Okay.
When we are comparing, let's say in join, merge, or in any other change capture.
Okay.
Okay. Now the next is collection method. Okay. In collection method, we are having the similar way. Currently, we have partitioned the data. Now we want to collect the data in order to load it into a target sequence. Okay. So similar way, there are 4 methods for it. First is round robin, in which from first data from first partition, then data from second partition, and then data from again from first partition. Okay. Then in ordered, all the data from first partition, then all the data from second partition. Okay. Then there is the next comes a sorted merge, in which the data is sorted, then it is collected into a sequential file. Means, suppose you want to have a requirement that you want a sorted data in your output, then you use this type of collection, in which the data from various partitions are sorted and moved in a order. Okay. And the fourth is auto. Like auto is the similar way. When you don't know which partition to which collector method to use, you can use the auto. Okay. Okay. Any doubts till now?
Yeah, I have a question on auto partition. How will be deciding which partition to use based on the stage? Is there any algorithm, inbuilt algorithm in Datastage like that?
No, actually it's defined totally internally. You won't have a look at it. Okay, you won't be knowing how it is using, but it is using the best possible partition which can be used for that state in that scenario in which you are building a job. Okay, you can't see anything, but if you want to use some external partition, that comes by your observation. Okay, like I said, you know entire partitioning. So for join or change capture, you should use hash partitioning. Now why we should use hash partitioning? You know about inbuilt sort, right? In a stage input tag. So using inbuilt sort, we need to define a partitioning. We can't use it with the auto partitioning. Okay. So in that case, you should know which partition to use with which state. Okay. Okay. So if we are using that, if we want to use inbuilt sort, we must define a partition. Since that, yes, you should know which partition to use with which state. Okay. Okay.
And for using the DB2 partition,
but you shouldn't be much worried, because most of the time, whenever you are going to use DB2 partition. Okay. Okay. So whenever you are using DB2 as a database for fetching the data, just divide partition as DB2. Okay. So it will have native like DB2 database also have a partitioning. So this will act as a native partitioning to that data, and the retrieval will be fast. Okay. Okay.
So while loading the data, we can use the same partition also, DB2.
Yeah. Okay. Yeah, this will increase the processing speed. Okay. Any other doubts?
No.
Okay. I think I can wind up my today's session with this. Tomorrow we are going to discuss like about the inbuilt sort. Then I'll give you a clear understanding of how data stage looks, and I will assume we can move ahead with the further training. And in my case, like daily, I am going to have a session of 1 hour, in which 30 minutes will be theory and 30 minutes will be practical moving forward. Okay. Daily I am going to teach you around 1 or 2 stages, and then we will have the practical forward. Okay. Data stage will be installed in your machine, in your laptop, and then you are going to use that. You can use anytime whenever you want. There won't be any constraints for you.
This server any time both will be installed, or only client will be installed?
No. The server will be installed in your machine. With database, you will have access to Oracle and SQL Server. Okay. We will provide you the complete suite along with Datastage. We will provide you Oracle and SQL Server, which can be used for your like daily testing, like hands-on. Okay. And regarding the version which I am going to install in your machine, it depends on the configuration of your machine. If your machine is having around 8 to 9 GB of RAM and 80 GB of hard disk, then 8.5 would work. If you have 4 GB of RAM and around 30 to 40 GB of hard disk, then the 8.1 would work.
Okay.
Okay. So it depends totally on your system configuration, which version I am going to teach. Okay. So any other doubts apart from this?
Yeah, one question I have regarding the repartitioning. Suppose for one stage I am using partition method A and for next stage I am using partition method B. So why we are changing the partition method? Why can't we keep the same partition? Why can't we propagate the same partition to other stages?
No, it depends. Basically, we can keep the same partitioning and it is preferred to have the same partitioning, but sometimes you want to change the partitioning. Okay, let's say in lookup you were using entire partitioning, and coming the next stage is join stage, so you need to have hash partitioning over there.
Okay.
Okay, so in that case you need to have different partitioning. So that's why we need a range repartition the data.
Okay.
Okay. So it depends on your requirement. Basically, it's never preferable to repartition the data. It increases the overhead in our job.
Yeah.
Any other doubts?
No, I'm fine.
Okay. Then I can wind up my today's session. If you have any doubts, you can give me a call or you can dial me. Okay.
Yes. Yes.
Okay. Thank you. Thank you. Thanks a lot.
Thank you.
Bye.
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 Bye.